Problem number 7 asks you to find the area of using the right and Riemann sum, the functions x squared, and we subdivide the interval into n subintervals. Therefore, the width of each one, the total length is 7. Therefore, the size of each one is 7 divided by n. And we want to find the right end point of each of those intervals. Well, I'm starting at 3, and each interval has a size of 7 over n, so it is 3 plus 7 over n. And the second interval, the right end of it should be 3 plus 7 over n twice. And then clearly the third one is 3 plus 7 over n 3 times. So I have my 3 answers here for my x1, x2, and x3. Well, because you can see the trend is like multiplied by 1, by 2, by 3. So it should have been 3 added to 7 over n multiplied by k, which is the right end of my case interval. When we talk about the general formulation, if I'm going from A through B divided into n subintervals, then the case interval where k could be 1, 2, 3, n minus 10, n minus 1, or m, the right end of the case interval is always a plus b minus a over n multiplied by k, where a is the left end, b minus a over n is the size of each interval, and how many intervals, which one, what's the index of the one you are in particular are talking about. So if I know the expression, then I plug it back into the function. So it's 3 plus 7k over n squared, which is my function value. I want to find the multiplication between the function value and which is the height of my rectangular region, and the delta x, which is the base. So I'm going to multiply those two pieces together. So I'm going to end up with 3 plus 7k over n squared multiplied by 7 over n. I understand I'm going to do sigma summation later, so I need to simplify it in order to carry out my calculation. So what I end up with is 9 plus 3 times 7 is 21, which means 42k over n plus 49k squared over n squared multiplied by 7 over n. So I can keep simplifying this, which is 63 over n plus 42 times 7 over n squared multiplied by k, add to 49 times 7, which is 343, divided by n cubed multiplied by k squared. So this should be able to answer the question. I know I need to do sigma summation later, so I FOIL out this term into that, and then I multiply out the expression. So this is what I end up with. When I try to do sigma summation of this, I'm going to have sigma of 63 over n, where k goes from 1 to n, where k goes from 1 to n. I'm answering this problem where I'm told to add all the variations of k together. So it's 294 n squared, and then 343 n cubed k squared. Well, you should realize that this expression, and this expression, they do not change when k is swiped through 1 through n. So the first problem is simply this number 63 over n add to itself n times, so it's multiplied by n. The second expression is 294 over n squared, summation k goes from 1 to nk, add to 343 over n cubed, and then summation k squared, k goes from 1 to n. Well, the first part is 63. The second part is 294 over n squared. Summation of k goes from 1 to n. It's n times n plus 1 over 2. And then in the class, we also provided you with summation of the k squared terms. I'm not 100% sure I'm remembering it correctly. I think it's 4n, n plus 1, 2n plus 1. I think there's no 4 in the front. Divided by, like I said, I can't remember it correctly. I think it's 6. Please double check. please double check the formula in our slides or activity number 26 or number 27, both of which are posted on Brightspace. So this is me doing summation, right? Add all the terms together. That's what I should have here. The next problem says, please send n to infinity. So I'm taking, actually, I have the formulation here. So divided by 6. Okay, that was correct. Okay, so the next thing, I'm taking the limit. So I'm sending n to infinity. If n goes to infinity, clearly 63 is still 63. The second term is n goes to infinity. This is n squared. This is n. So those are both n squared terms, the polynomial. Therefore, as n goes to infinity, it's the leading coefficient, the ratio of the leading coefficient, which is supposed to be the answer, which gives me 294 divided by 2 along the same line of thinking. This is an n cubed term. That is n 2n. So, okay, sorry about that. So that's supposed to be a cubic polynomial over a cubic polynomial. So again, it's a leading coefficient. That's going to be my ratio. So it's 343 times 1 times 1 times 2. So 343 times 1 times 1 times 2 divided by 6, which is a leading coefficient on the denominator. So it's divided by 6. So I can find my answer pretty efficiently. If this doesn't make sense, please go back to our class recording in which we went over activity number 26. So you can try to understand this discussion one more time.